Hi, my name is John Frensley, and I teach math and physics. Do you have any idea how many math hands on activities you can do with a basic soda bottle that looks like this, with a hole in the side of it like that right there? This I got from Dollar Tree. It's a 3-liter bottle. It had some watered down, janky lemonade in it. So I bought it. Ain't Dollar Tree no more. It's $1.25. It's 5 quarters, what they should call it. So I buy it for 5 quarters. I dump the janky lemonade down the drain, and then I get to do a bunch of activities with this with my students, right? So I want to tell you about some of them. I can think of like 10. I'm only going to tell you about a few, right? Okay. So, because I don't want to bore you to death. I want you to imagine that that's the ground, and maybe you have a platform like this. Could be a table. Maybe you could take your students outside and have some portable tables. Or at my school, there's a loading dock, and we also have a nice courtyard with some different steps on it and kind of thing like that. So what do? You're going to take the bottle. All right, there's a bottle right there. And you have the hole, and you're going to fill up the bottle. You're going to pee out of the hole. Yeah, it looks like peeing. Your students are going to think it's funny as heck. And I don't honestly care, right? Okay, so what are you going to learn from this? Let me tell you some things. So first of all, if you lay yardsticks or meter sticks along the ground, and then what you do is you make a table of time, which you can call X, and distance the water goes, which would be this distance right there. If you just do this and you maybe take this distance every 10 seconds, it turns out when you graph the data of the distance the water goes versus the time, you'll actually get dots that form a line. Oh, wait a minute. I'm sorry. They don't form a line like that. They actually form a line with a negative slope because as the water pees out, it goes slower or shorter and shorter and shorter and shorter distance. So the line is actually a negative slope. And then when the water stops coming out is this moment right here. So what could you do with this information? Maybe what you could do is there's a lot of things. Maybe what you could do is you could have students only take maybe the first, 25 seconds worth of data. So every 5 seconds, they're going to take data. And then after that, they have to give your bottle right back to you, or they have to dump the bottle. Like you say, like you time it. You say, okay, everyone start, beep. They all start their stopwatches. Okay, now everyone stop. Now I have to dump out your water. And then you say this, I want you to predict how much time it takes from when the bottle is completely full, or at least maybe up to this part where it starts curving. How much time does it take for the water to completely come out? So what would the students then do? They would make their line. They would construct a y equals mx plus b. So they would have to get the slope and they'd have to get the intercept. And then they would have to figure out, okay, this is where where y equals 0 is at this time. And then they would say that's their prediction. And then you say, okay, now let's actually try it. Now you're going to actually you're just going to time it until it stops peeing out. How close is your prediction to the honest truth, right? So this is a nice little lines activity. Well, let me tell you something else. This shape right here is a parabola. So do you want to explore parabolas with your students? What I'll do with my students is I'll make it so that they have to keep the water at the same level every time they take data. They'll lay out yardsticks or meter sticks, but then what they'll do is they'll measure with another yardstick or meter stick this height, this height, this height, this height. So what they're getting, assuming that this is the origin, like y, x, what they'll get is they'll get different y heights for different x's, right? So they'll be like maybe 2 inches, 4, 6, 8, 10, or maybe you could say 10, 20, 30, 40, 50, 60 centimeters, height. The only rule is that they have to keep the water level the same. So they have to have maybe a funnel, which you can buy from Dollar Tree, and you can pour the water in just every time you're going to take data, so it's at the same level, right? So what are they going to do? They're going to construct a y versus x. They're going to construct a parabola out of this, and then they may need to talk about why it is. They might use a quadratic regression on Desmos that I'll teach them, or they have to build it like knowing that this is the intercept right here. So, and this is the vertex. So because this is the vertex, B should be 0. And then they're going to say, okay, well, this height right here is C. So maybe I don't let them use Desmos. It depends on how I feel each year that I do this. And then they'll plug in the C, and they'll plug in this distance for X, and they'll solve for A. So now that they've constructed this, here's what I'm going to tell them. I'm going to say, hey, you know what? As long as the water's up to the same height, the A is the same. But now what I'm going to do is I'm going to take your bottle and I'm going to hold it as high up as I can, or I'm going to put it on some higher shelf or surface. And so what that means then is that they now have to do a transformation, and I'm going to have them put a cup where they think the water is going to land, and they're going to do that by simply doing a transformation. Same A, but now the C is the new height of the hole, right? So that way, so that's something you can do to study parabolas. Here's another thing. Let's say that this is the height of the water in the hole, right? Well, if you take time and height data, just time, height, while the water pees out, that's also a parabola, it turns out. It turns out that a height versus time graph looks like this, and this intercept, that vertex right there, is when the water stops coming out of the hole. So that's one of the ways I have my students learn about parabolas, right? Now, here's another thing. What if you graph this distance, which I'm now going to call D, the distance it pees out, as a function of this height? So we're going to try different heights and try different distances. So you'll do distance versus height. Try this and see if I'm wrong. You'll actually get something that looks like a square root curve. It actually is a square root curve. So when I'm teaching radicals, then I'm busting this out and I'm having the students construct a square root curve. And then I'm going to have them guess, okay, well, what if I make the height even taller, right? I might make them only test the bottom half or something like that. Okay, what if I make the height all the way up to like this little piece right here? How far will it go, right? They have to extrapolate from their square root function. So there's all kind of things you can do with one of these. I haven't even gotten into things that junior high students can do, like learning about the basic idea of functional dependence, the idea that the distance D depends on the height H. Like if the height H is the same, the distance D is the same, that's a function. And only one distance D aligns with, is associated with the distance H. That's a one-to-one function and things like that. There's some geometry you can do where you can talk about like how much volume, so how many cups could you fill up and things like that. For calculus, there's related rates. So there's all kind of things that you can do with one of these. So let me tell you really quickly how to construct this. You just dump out all the water in the tube. And now a lot of teachers think that all you have to do is take a pencil or a sharp pen and just jam it into the plastic. That will not work. What you'll get is this weird kind of tinkling spray that comes out. No, you need a solid stream. So here's how you're going to do it. What you're going to do is you're going to get yourself a nice 1/8 inch nail like this, 1/8 of an inch in diameter. Then you're going to get yourself some pliers. Then you're going to go to your science department. You're going to say, hey, can you do me a favor? Can you set up a Bunsen burner for me and turn it on? I don't know how to do that. Okay. So then they turn on the Bunsen burner. So let's say that this right here is the Bunsen burner, right? So you're going to this in there. Doesn't even have to be red hot. But if it gets red hot, that's hot enough. Then you just gently, very gently just press it in. And man, the nail just goes right through with no effort. So you just gently press it in and it cauterizes that. It makes this very thick right here and the stream comes out and it's glorious. I'm not going to show you that in this video because I don't want to put a bunch of water on my floor. But what I hope that you'll think about is whether you'll try some of these activities. And if you're interested in even more activities, stay tuned in this video and you'll see an advertisement for a summer workshop I do where we do all kinds of hands-on activities and math-based games and all kind of other fun, out-of-the-box math stuff. Well, if you like this activity, I am wondering if you knew this. You can use things like a golf ball to teach ratio, average, linear equations, things all the way up through geometry, piecewise function, parametric equations, all the way up through infinite series in calculus. Do you know that you could use a soda bottle to teach things as simple as functional dependence at the junior high level, all the way up through related rates, all the way through calculus? What if I told you that you could use a pencil, ruler, and coins in order to do things like geometric scaling or the Pythagorean theorem or linear equations? I forgot to put on here rational functions, right? That you can do ratio and proportional and reciprocal functions and sinusoidal graphs just using a straw and a tuner or these little pop tubes, right? That you can do quadratic functions and parametric equations with a dart launcher. You can do rational functions and asymptotes or even teach basic domain and range with a lens and a flashlight, things that you can get at Dollar Tree quite easily. That if you have a water and a thermometer, that you could do exponential decay, that you could teach things as complicated as slope fields and differential equations. These are all things that you can teach at whatever level of math you teach using basic stuff that you can find or buy just from Dollar Tree or from really cheap places. What about games? What about math-based games where you could go from, basic sixth grade adding up rational numbers to games where students are shooting y equals mx plus b lines at each other, or they're shooting inequalities at each other, and there's actual strategy to it, right? What about sinusoidal graph wars that they shoot sinusoidal graphs at each other, or they punch each other out with complex numbers, or they chase each other with the Pythagorean theorem and things like that? Is this stuff that you would want to do in your math class, playing games and doing hands-on stuff? Would you want to do some performance-based assessments, right? I'm not asking you to get rid of your traditional tests, but something that's more open-ended for students, right? What about integrating little writing pieces into your application problems, right? Your word problems, where students have to write a little bit, not just solve the problem. Is that something that you think would be valuable for your students? Is that something cross-curricular that would make you a leader on your campus? What about, would you like to see some methods of remediating tests and quizzes, right? Things where students are getting not only individual feedback, but individual remediation without you having to sit down in front of every single student. Would you like to integrate some basic computer programming in your math course? If any of this is interesting to you, I think that you ought to come to my Summer Institute for Math Teachers. This summer, it's July 15th to the 18th. I teach physics and math. My forte is teaching physics teachers how to make their classes more hands-on and engaging. I've started doing that for math also. Last year was our first Summer Institute. We had 12 participants. They all thought it was pretty neat, the things that they could do with their students. It was much more engaging and fun and things like that. So if you go to findphysics.com, click on Math 2024 Institute, then you'll see the information. Here's some information. It is in person because there's so much hands-on stuff. But we have a discounted rate if you are, the venue is a hotel conference room, so you would get a discount. Your district should be paying for it, obviously, so they would get a discount. We cater lunch every single day, so we provide you with the food. We provide shuttle service to and from the airport, so you don't have to rely on an Uber. You don't have to rent a car if you don't want to. There's lots of dining and entertainment within walking distance. So if this is something that's interesting to you, visit my website. You can contact me through the contact page there, or just look at the Math 2024 Institute. You'll see pictures from last year. You'll see a session agenda and all kind of really cool stuff. And I hope to see you there because I think that you can really jazz up your math class with some cool hands-on stuff, with some games, and just with some new instructional techniques that make math really interesting and fun to be a part of.